what we have in this table is the values true or false for the ignition switch, which can be either on or off. On is equal to true and off is equal to false, of course. And we have the values for the exit the vehicle switch, which can also be either true or false. So when the exit the vehicle switch is true, that means we want to stop the program, and when it is false, that means that the program continues running. One more important thing is to cover all the four possibilities, since each of these switches, and there are two of them, has two options, either true or false. It's 2 to the second number of total possibilities available for the combinations of these two switches. So we go true, true, false, false for one of them, and then true, false for the other, so that we have covered all the variants. For the result, so this is what should happen to the LEDs. Okay, so if the ignition is on and we exit the vehicle, the LEDs should not light up. So this is the case that I have pointed out would not be acceptable if we were working with hardware. So it shouldn't be actually acceptable even if we are working with the software. When we stop the program, the software LEDs should also be off. So this is our main problem. Other variants include ignition is off, we have not exited the vehicle, so the LEDs should be on, at least one of them, or exactly one of them. When the ignition is off, the LEDs should of course be off. So this is very simple, this is obvious to implement. So this is actually the type of the solution that we have had applied, but in this second or the first part of the table there was a problem with this here function. So when this is true and this is true, currently this is also true, and we don't want it to be true. That is because ignition was directly forwarded to the LEDs depending on some other conditions, but I'm talking of the whole LED block. So some of them are true, or one of them is true at the point when ignition is true. So we need to change this.